The topic of this video is using the distance formula. Consider the points 1, 5 and 4, 9. The distance between the points is shown below. Notice that you can construct a right triangle using those 2 points as the endpoints of a hypotenuse. All right, let's look at this diagram. So if we measure the distance horizontally from the point at the bottom left to the point at the top right, we find that we are comparing the x-coordinates to find that distance. The x-coordinate of this point is 1. The x-coordinate of this point is 4. So if we want to know how far it is across at the bottom of this triangle, it would be found by subtracting 4 minus 1, or if you prefer 1 minus 4, then you would just have to take the absolute value because a distance cannot be negative. So you can subtract the two x-coordinates and take the absolute value, and that'll tell you how far apart these points are. That'll tell you the horizontal distance. For the vertical distance, very similar exercise. Now we're measuring the up-down distance from the point at the lower left to the point at the upper right. And this time we're comparing the y-coordinates, 9 and 5. So if I want to know how far this distance is, I just need to subtract 9 minus 5 and take the absolute value, which is 4. Or if I wanted, I could subtract in the other order, 5 minus 9, and then take the absolute value, which is 4. All right, so we can see there then our triangle has legs of lengths 3 and 4. So by the Pythagorean theorem, a squared plus b squared equals c squared, we plug in and we have 3 squared plus 4 squared equals d squared. 3 squared is 9, 4 squared is 16. So 9 plus 16 equals d squared. Of course, 9 plus 16 is 25. So now I have d squared equals 25. Apply the square root property. D equals plus or minus the square root of 25. The square root of 25 is 5. So I get d equals plus or minus 5. But because a distance cannot be negative, I'm going to make my final conclusion, d equals 5. So the distance from these points to each other is 5. The distance from one point to the other is 5. We can generalize this process by changing the points from 1, 5, 4, 9 to the generic points x1, y1 and x2, y2, as shown in the figure here. In this instance, the A part of our diagram is found by subtracting the x-coordinates and taking the absolute value. The B part of our diagram is found by subtracting the y-coordinates and taking the absolute value. And then by plugging into the Pythagorean theorem, we would have x1 minus x2 squared plus y2 minus y1 squared equals d squared. Notice that we don't need the absolute value bars anymore because when you square something, it becomes positive. Solving this equation for d and dropping the plus or minus symbol because a distance cannot be negative gives us the distance formula. D is equal to the square root of, parenthesis, x subscript 2 minus x subscript 1, close parenthesis, squared, plus y subscript 2 minus y subscript 1, all in parenthesis,